Let's understand FreeRTOS today like a story. Imagine this world of embedded systems, PCBs, is your world, and you're the mayor of this world. Now it's your job to manage this city and this world. So let's move on to our story. Chapter 1. Welcome to Task Town. What is Task Town? Imagine each task is a worker, right? And your world is full of workers. Okay? Look at this poor worker. How happily he's doing his work. But the sad thing is, when we were coding a normal STM, this same worker was first digging a road, then hammering nails, then blinking an LED, and also communicating. The poor fellow became incredibly burdened. The workers' community became deeply displeased with this entire system. Then, as a mayor, you introduce a new system called FreeRTOS. And what does FreeRTOS do? It says only one worker will do one task. A worker won't do more than one task. One worker will dig the road, another worker will blink an LED, another worker will communicate with the user, and another worker will hammer a nail. If each worker performs a single task, we can call each worker a task. Task 1, Task 2, Task 3, Task 4, right? So FreeRTOS is made up of tasks. Each task, each action represents a task. And each worker runs independently and uses the CPU in turn. Okay? You can see this. This is how we define our tasks. We write a void function with no return type. Then we write a while loop. Inside the while loop, we write whatever task we want to perform. And this delay function, this is just to replicate that this task took 500 milliseconds. Alright, so this is how we define tasks in our FreeRTOS program. Chapter 2. Giving jobs to workers. Now that's a worker. They're performing some task, right? So it's necessary to assign them a job. Otherwise, why would they be working at all? So how do we create a job or a task? To create a job, we first need to provide attributes for that worker. For example, what's the worker's name? What's the worker's priority? How important is their work? And the stock size. In other words, consider how much food and energy this worker will need to perform. We need to specify that. Once we provide these attributes and our task is already defined in the function, we create a new thread. This thread runs our task, attaching these attributes to it. This way, we create a task and run it in our world. But how does this work? It needs to be scheduled. And to schedule this, we need a FreeRTOS scheduler. You can think of it as a mayor fulfilling your responsibilities in your world through the scheduler, scheduler. So, how do tasks get time to work? FreeRTOS has a scheduler. The scheduler is like a smart mayor that assigns each worker their chance to work based on their task importance, which we saw as priority in the previous slide, and whether the task is ready to work, whether it's not stuck in a task that's waiting for the previous task to complete o siya or whether it's not sleeping. If it's ready to work and its task is important, the scheduler will schedule it. And that task will run taride. So, this is a drawback of classical computers, where the CPU, the brain, can only assign tasks to one worker at a time. Right? So imagine if you're watching 4 tasks running simultaneously on any of your devices. They're happening at such fast intervals that you think they're happening all at once. In fact, they never happen all at once, too. I'll start a task. These commands, OS, kernel, initialization, MX FreeRTOS initialization, and OS kernel start. By writing these 3 lines in our code, our kernel, our operating system starts up and our task begins. Chapter 4. Delay is not sleep snap. You may have noticed in the previous slide that I used OS delay instead of help delay. And why? When we use OS delay, imagine we're using OS delay 1000. That means worker go take a nap for a second, then come back. And when that worker sleeps, the other workers will continue working. But what was happening in the held delay was that when I used held delay, when it would sleep, the entire system would come to a standstill and no one would be able to do anything until then. That's why OS delay is important, and we use OS delay in FreeRTOS applications. This story ends here today. We will see the next chapters in the next video. We hope you liked the video. If you liked the video, please like it. If you are new to the channel, then subscribe to the channel and tell us in the comments how you liked this video. Thank you. Bye.